find the domain and range of the function f of x given by this formula here. So it's x plus 2 over 3x minus 7, all raised to the power 5. Okay? Now, if the question just asked for domain, you'd say, okay, I'm seeing division, I'm seeing addition, I'm seeing multiplication, I'm seeing subtraction, I'm seeing exponents, all basic arithmetic operations. Finding the domain shouldn't be that bad. And that's perfectly fine. Domain wouldn't take too long in this case. But range is a little bit harder in a lot of cases, just because there aren't a whole lot of clear-cut, oh yes, you see this, therefore this such and such can't be 0, so x has to be bigger than 7, and things like that. Range can be a little trickier, but a great thing you can do with the range is the range of a function, like this one here, is the same as the domain of the inverse of this function. Okay? And we might be able to find f inverse, and from there, get the domain. Okay? And then that'll be the range, and that'll get the second half of this question. So we'll do the domain first. When I look at this, what are the sort of forbidden arithmetic operations? I don't see any even roots or anything like that. The only thing that I see that could go wrong is this division in here. Right? You can always raise things to the power 5, stuff like that. You know, there's no roots, and even if there was, it would probably be a 5th root, and that's fine. But the only thing that isn't allowed, okay, 3x minus 7, it can't be 0, right? So when is it 0? When is this going to fail? So we can bring the 7 over to the other side. So 3x can't be 7, x can't be 7/3. That's it, simple as that. So if I wanted to, I could get the domain here. Say the domain of f is everything less than 7/3. Let's actually make that 7 look proper. Or bigger than 7/3, so using our interval notation. Great, that's it. That's it. This expression is fine as well, but interval notation is nice and precise, and everyone should know how to read it, so it's good to leave our answer that way. Okay, so that's the domain, but again, range can be a little bit trickier, so the strategy I'm going to use is let's find the inverse of this function. Okay? It's not the only option. You probably could do a lot of work with inequalities to try and make this, get the range that way, but it's a good skill to have, is finding inverses. So we're going to copy our function down. It's taking me a little bit of back and forth here. It's x plus 2, I think it was 3, yeah, it's 3x minus 7 because we just solved it, and then to the power 5, right? Let's just double check. Always want to double check when we move over to scrap paper so that we're not doing the wrong question. Yeah, x plus 2. Okay, good. So I am going to find the inverse of this function. How in the world do we do that? So you start with an equation where the output, y, and the input, x, are represented. Okay, and then we're going to swap x's and y's. So x is y plus 2 over 3y minus 7, all to the power 5. Okay? Why are we doing this? Because inverse functions swap inputs and outputs. So now the question is, can I do some math to get y equals something? And that something would be the inverse. And once I have that, it should be a nice algebraic expression with just arithmetic operations, and we can do the same trick to find its domain, which would then, of course, be the range for f. Okay, so the first thing that probably jumps out at you, certainly jumps out at me, is, there's multiple y's here. Okay? This is a common thing that can happen with slightly harder questions. There's multiple y's, so what we're going to have to do is find a way to group them together, consolidate them, and then factor some things out and get just one y. Okay? Before we do that, I can't get to any of these y's, right? We're trying to isolate y because we got this pesky to the power 5 there. So what I'm going to do first is I'm going to cancel out the to the power 5 by taking the 5th root of both sides. And then the power 5 and the 5th root cancel out. So what we have is the 5th root of x is y plus 2 over 3y minus 7. Okay, a little bit better. Now, what else can we do? Well, what I usually like to do is I say, okay, there's multiple y's. There's 2 y's here. Sometimes there's 2 y's, sometimes there's 3 y's, sometimes there's a lot of y's. But let's get all the y's onto the same level. And so what I mean by that is let's bring this factor up top. And the way we do that is we multiply both sides by 3y minus 7. Because then if you multiply by 3y minus 7, it cancels out the 1 down here and effectively just moves it up. Why is this nice? well, now all the y's are on the same level. The reason that's a good thing is because maybe we can move them all to the same side and get them even closer, and then find a way to merge them into 1. Okay? So I'm going to copy over what we have. We have 5th root of x, 3y minus 7, y plus 2. Okay? I'm going to expand this out just because I want the y sort of free. So we'll have 3 5th root x y minus 7 5th root x equals y plus 2. And then here's the plan. We're going to get all the y's onto one side and everything involving x onto the other. So we'll have 3 5th root of x y minus a y equals, and then we'll have 7 5th root of x, just bringing that to the other side because it's got no y's, plus 2. Well, now, all the y's are together on the other side, and what we can do is we can factor them out. So we'll have a y here. Now we had 3 5th root of x here, and then we only had 1 y, so we take away, divide by y, you'll be left with 1 here. Okay? And that is the common strategy. If you got multiple y's, get them all onto one side in an expression like this so you can factor it out. Now 2 y's or 10 y's turns into 1 y. And now we're one step away from being done. We want y. Let's just divide this out. So 7 5th root of x plus 2 divided by 3 5th root of x minus 1. Okay. There it is. We have 1 y. We have no y's over here. So this must be my formula for f inverse of x. Now the whole reason we did this is because it's probably easier to find the domain of this than it is to try and find the range of f just from the formula. So let's go through it now. F inverse has this formula. It was 7 5th root of x plus 2, and then it was 3 5th root of x minus 1. And as we did before, we say, okay, what things are not allowed? Well, I do see roots here, but they're 5th roots. Odd roots, nothing wrong with that. So just like the start, the only thing that's sort of forbidden is there might be a division by 0. So we need to not have 3 times the 5th root of x minus 1 be 0. That's not allowed. So we can't have 3 times the 5th root of x be equal to 1. So we can't have the 5th root of x be equal to 1/3. So we can't have x be equal to 1/3 to the power of 5. Okay? It's fine to leave it like that, I would say, but you can multiply by 3. So 3 times 3 is 9, times another 3, 27, times another 3, 81, times another 3, 3 times 8, 24. So there's absolutely no harm in actually working out what that is. 1 out of 243, or 1 243rd, but x can't be that. Every other number is allowed. So if we, actually, let's just go back to the original question. So anything other than that is fine. And so that's the domain of f inverse, but that is, as we know, the same as the range. So the range is everything other than 1 243rd. And there we go. Domain done, range done, all done. And no one asked me for it, but I also have the inverse to this function as well, which is maybe powerful, maybe useful if there was another part to this question.